Again, everything off your desk except your Chromebook. I'm going to demonstrate what you have to do in this lab. And then I'm going to have you pair up to get the data with somebody. So that way you can kind of split your efforts to get the data. And then we're going to work on making all of our graphs together because the graphs are a pain in the butt in this lab. Okay, so we're going to do them together to make sure you all get them right. And then we're also going to answer the questions all together. If we are able to work through this quickly together, okay? Whatever we don't finish on the lab and get done in class together, you're going to have to finish for homework and submit it before tomorrow's class. Yes? So let's go. That way we can get it done and you have no homework tonight except studying and reviewing your notes. Sound good? All right, so go ahead and open up the lab. This is lab 10 on horizontally fired projectiles. You're going to see two things in this lab that are posted for you. We have the Google Sheet here, and you have a simulation here. I want you to, whoops, the screen is frozen, sorry. You have both the lab, Google Sheet, and the simulation. Open up both of them. Simulation and the Google Sheet. And I'm just going to make a copy of this for me. You're not making a copy. Keep it as exactly it is. I have to make a copy. Otherwise, next time I push this assignment out to students, they're going to have all my information already typed in. It's like I edit the master file. I don't want to do that. As a teacher, I have to do this. Period 5. And you guys are 2023. You're not doing that. Okay. So here we are in the lab, and what we're going to be doing in this lab is determining what factors affect the motion of this horizontally fired projectile, which is the one we were just starting to do some practice questions with. So we've got our website open, and in this simulation, I want you to click on that intro tab. And I want you to notice that we'll be using this for our next lab as well. We've got a cannon on the top of basically a cliff. There's a statue here. There's a target here. You can move the target wherever you want. It really doesn't matter. We can move the statue too, I believe. Oh no, the statue is fixed in its position. We can adjust the height of the cliff by clicking on that height. You can make it taller or shorter. We can adjust the angle that the barrel of the cannon is at by clicking on the barrel and adjusting it. In this lab, folks, you want the barrel to be at 0 degrees. Please adjust that so it's at 0 degrees. Now, I also want you to adjust it so the cannon's height is 10 meters. So go ahead. You can click on that plus sign, and that will adjust it. Move it up to 10 meters. There we go. The other things we can do here is we can change the initial speed with which we're going to fire the cannon. Right now, mine is set to 15 meters per second. You can adjust it with either the arrows or dragging and moving the blue slider bar. We can fire the cannon by clicking this red button. I'll show you what that looks like in a minute. But come over here to the right side. This is where we can have a little fun. You see this drop down? You can change what you want to fire out of the cannon. Look at our options. There are some of there that are a lot of fun to shoot. I never fire the piano because seeing the piano hit the ground and breaking apart just hurts me. No, none of this will affect your data. But I'm going to stick with something that's relatively small. Or the other one that's always a lot of fun, I'm going to shoot the human out. I think that's what I'm going to do. In this lab, I'm going to shoot the human. And I can put air resistance on or off. In this lab, we need air resistance off, so that should be unchecked. I don't want to see any of the vectors on this. And I've got some measuring tools here. I've got a measuring tape, and this one can be used to measure the time, the range, and the height at different points in the projectile. But let me just show you how this works, for example. To fire it, there goes that person. They hit the ground, and now they're standing up on the ground. Do you see that? If I want to get that person off the ground, all I do is this is an eraser. I hit the eraser, now they're gone. And it resets everything for me. Okay? So let's look at what we want to do in the lab. We have it set to 10 meters at 0 degrees. We're now going to go to part 1, and we're going to look at testing the initial speed and how that changes things for this projectile. So you'll see in this data table that these are the parameters I want you to set for that person or whatever the projectile is that you're firing. We're going to start with a height of 10 meters and a speed of 2 meters per second. So come back into the lab. I've got a 10-meter height. I need to reduce my initial speed to 2 meters per second. There it is. And now I'm going to fire it. Okay. Now, up here on the top right, I want you to click and drag this blue measuring tool. And you'll see that there's a crosshatch here in the middle. To measure the time in the air and the range, you want to move that crosshatch so it's at the very ground. And you'll see that when you get to the point where it hits the ground, you'll see it lights up. You see it lights up on the ground when you have it measuring? Does yours do that? Some of you are not answering my question. I asked you, is it lighting up when you move it there? You want to make sure it lights up, otherwise it's not, you're not measuring in the right spot. Now, here is the time measurement, and there's the range measurement. We have to type those into our data table. So let's go into our data table. The time was 1.43 seconds. We just type 1.43. We don't put the units. And the range was 2.86. We're all going to get the same values. Notice that I then want to repeat this for different speeds at that height. Yes? Okay. I want you to move on to part 2 for a minute. In part 2, we're doing the same thing. Can everybody look at up here? In part 2, we're going to reset this so the cannon speed is now 15 meters per second. Notice that every trial we do will have an initial speed of 15 meters per second. Here, what we're doing is changing the height, and we're going to measure the same things, the time and the range. So let me do the first one in this table with you. We need a height of 2 meters. Well, let me erase everything. I want a height of 2 meters, so I'm dragging it down to the ground. And I want the speed to be 15 meters per second. There it is. I'm going to fire it. And I'm going to move my blue measuring tool here to the ground. And you can see the time is 0.64 seconds and the range is 9.58 meters. So let me go ahead and type those into this table. That was 0.64 and 9.58. Now, I'm going to tell you right now, I told you I need you to pair up with somebody. We have an even number of people here today, so that will work. We're going to pair up just with the person sitting next to you. So I'm not going to have everybody moving all over the place. Cam, I'm going to have you collect data with Caitlin. Janelle, you're going to collect with Emily. Pia with Olivia. Addie, you're going to collect with Savannah. Ashley, collect with Josh. The two of you are together. Dakari, you're going to collect with Nick. Brandon, you're going to collect data with Fig. Here's what you're doing. You have a partnership. One of you is going to collect the data for part 1 and fill in this table. The other person is going to collect the data for part 2. Then, once each of you is done, guess what you're going to do? Share the data with the other person in your partnership. That way, it's quicker to get the numbers. Once everybody has all their data, we're going to work together on moving into these graphs. Okay? Because the graphs have to be done together as a class because it's kind of tricky. All right? Good? Okay. So, Caitlin, why don't you scoot down a seat? Go ahead. Get your data. then once you get all of the data, you can close out that simulation. So that way your computer isn't quite so bogged down with things being open. I know your Chromebooks have a hard time processing things. Brandon, why don't you scoot over next to Fig so that way it will be easier to share data. Again, once you have all your data, share it with your partner. See, this is how we speed up the process. Instead of having you collect 2 data tables worth of stuff, you're just doing 1. It's just repetitive. So save everybody a little bit of time. And you can pack up everything else. You don't need anything but this Chromebook. The whole lab is done on a Google Sheet. And there are no calculations for anyone to do. Okay. Anyone still getting data? So everybody has both data tables filled in 100%? Because like I said, these graphs are a pain in the butt. You're going to need to follow along with me carefully. Okay, don't jump ahead because the graphs on this one are really finicky. I don't know why Google Sheets has a hard time with these graphs. Okay, so let me show you what we're going to do. Everybody with me? Let's look in part 1. Everybody go to part 1, where we tested what happened as we changed the initial speed. First of all, just let's look at the data. What do you notice about the time for everything? It was the same. It doesn't matter how fast you shoot the thing out, it's always going to land in the same time, which is kind of what we talked about the other day. So, it's the range that changes, meaning how far out it goes. You notice the faster I shoot it, the further out it went. Right? Did you get the same results? Okay. Let's now look at step 2, where we're going to make a graph. There's 2 graphs we make in this part of the lab. Yes?
I didn't get the same results, so should I change mine so that they're the same as yours?
No, don't change them. Stick with what you had. Okay, so I'm just going to double check. Did you get the same times?
Yeah.
But you're not getting the same ranges?
No.
2 times 1.43 should be 2.86. Are you sure you had air resistance off, or did you put it on?
The 2.86 was fine, but then the rest of them were off.
4 times 1.43, 5.72. And that should be 1.43, 6 times 1.43, 8.58. That should be right, 8.58. Well, I'm just wondering, you're not getting 8.58 when you do it?
No. Yeah.
You should be getting these numbers. Yeah, the only thing I can think of is that you didn't have the blue measuring tool in quite the right spot to get those ranges. If your times are the same, this is what you get every single time. There's no other way. Okay, so anyway, step 2 wants us now to make a best fit scatter graph of the time versus the initial speed. And the graph has to have the title, the variables labeled, scaling, which means we want to see a clear 0, 0 on each axis, trend line, and equations. So let's take a look at where that is. We want to graph the time here in this column and the initial speed in the column to the left. So here's what I want you to do. Put your cursor where it says initial speed in meters per second. So that cell, which is cell C2, is highlighted, just like I have on the screen. Everybody with me? Hold down your shift key. Hold it down. Right arrow over. So now time is also selected. Keep the shift key down. Don't release it until I tell you to. Down arrow until you get to the speed of 18 meters per second. So you have this rectangle now highlighted in blue, like you see on my screen. Everybody good? Okay. Now what we're going to do is go up to our insert menu. Oh, I just lost it because my menu's disappeared. Let me try that again. And we're going to insert our chart. All right, let me walk you through everything on both tabs here in the chart editor. Start with the setup. Change the chart type to a scatter type, scatter chart. Now check your data range. It should be C2 colon D11. The x-axis should be the initial speed because that's what you were changing from trial to trial. The series should say time in seconds. And now, head down below, we need both of these boxes checked off where it says use row 2 as headers and use column C as labels. Do you have both of those checked? Yes? Okay, now go to the customize option with me. The first thing we're going to do is start with our chart and axis titles. Expand this menu. The chart title is the time versus the initial speed. Now, to go to the horizontal axis title. This is the initial speed in meters per second. Let's do the vertical axis title. This is the time in seconds. Okay, I'm going to collapse that submenu. Now notice we don't have a y-axis on our graph yet. Do you see that? There's no y-axis because we don't start at an x value of 0 meters per second. So to change that, go to the horizontal axis submenu, head down to where it says min and max. Type in a minimum value of 0. And as soon as you do that, now you get the y-axis to appear in bold on the left side of your graph. Is everybody okay with that? You always want to have that. Okay. Now collapse that menu. Now we're going to go to the series option and add our trend line. So click trend line. Linear is the default. Does that look like a linear graph to you? I agree. Now go to the label and say use equation. We don't show the R squared. Just say use equation. And this is what it should say, time in seconds for the blue dot, and the legend should show that the light blue line is 0x plus 1.43. Yes? All your graphs look like that? Okay, click and drag this graph. Dakari? No max, just a min of 0. Horizontal axis. Click and drag this graph and bring it down into step 2 in that yellow shaded space for step 2. Now my graph is a little too big. It starts to cut off question 3. So what I'm going to do is make my graph a teeny bit smaller so I can read all of question 3. There we go. Now I'm going to go to question 3. Can we all do that together? Now I want a graph of the range versus the initial speed. Here's where we have a problem. The range is here in the far right column. The initial speed is not adjacent to it. This is the easiest way to make this happen. Put your cursor where it says initial speed in meters per second. Shift key, hold it down. Right arrow over until you get to range. And then down arrow so all 3 columns are highlighted. This is where the pain is. Just go with me. Watch what I do and then just do it. Everybody has that? Okay. Insert your chart. Change the chart type to scatter. And your data range should be C2 colon E11. You have that? C2 colon E11. The x-axis should be initial speed in meters per second. Okay. Notice now it wants to put 2 things on the series. That means the y-axis. We only want one of the 2. We do not want the time. So you see the 3 dots here next to time? Click it and say remove. Now you're just going to have one set of data on the graph, just the ranges. Okay, that's the easiest way to just get the 1 on there without trying to unselect a column. It's just, this is the easiest way. Head down now, say use row 2 as headers. Everybody good? Okay, go to customize. Chart and axis titles. Let's start with the chart title. This is the range versus the initial speed. Range versus initial speed. Okay, let's go to the horizontal axis title. This is initial speed in meters per second. Vertical axis title should be the range in meters. Okay, collapse that submenu. Again, I don't see a 0, 0. Do you? Okay, so do you remember where that is? Go to the horizontal axis menu Head down, and this is where you're going to type in the minimum value of 0. Takari, do you have that? Okay. This time we're good. Everybody now has a clear X and Y axis on the graph. All right, now you add your trend line, which is under the series option. Does linear look like a good fit? It is. And now you have to add the equation to it. So click the down arrow for label and say use equation. And now we should have the blue dot says range in meters, and the light blue line is 1.43 times X plus some really tiny, 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 tiny number. Yes? Okay, click this graph and bring it down to the space for question 3. Where is it? And I think that's it on part 1. Everybody good with part 1? Okay, because now it says go on to part 2. So let's go to part 2. Here's my data for part 2. We now want to, from that table in step 2, make a scatter graph of the time versus the height. Again, these columns are not adjacent. So put your cursor where it says height in meters, shift key down, right arrow over to time, and then come down until you get to the height of 14 meters. Everybody good? Okay. Now we're going to insert our chart. Change the chart type to a scatter graph. The data range should be B2 colon D9. B2 colon D9. The x-axis should be height in meters. The only thing we want is the time on the y-axis, so initial speed in meters per second. Click those 3 dots and say remove. Everybody with me? Okay, head down still. You must select the box that says use row 2 as headers. Good? Okay, go to the customize option, chart and axis titles. Let's start with the chart title. This is the time versus the height. Let's now go to the horizontal axis title. This is the height in meters. The vertical axis title is the time in seconds. Collapse that submenu. Let's go to the horizontal axis. Do you see we don't have a 0 on the x-axis? So type in your minimum of 0. Okay. Now we're going to go to the series option. Click your trend line. Does that look like it's fitting all the data? No, it's not. Okay, so here's what we have to do. We have to change the type. This is not linear. There's only 2 types of curves we work with, polynomial and power. So let's try polynomial first. That's okay, but it's not great. And let me tell you why. Think of this. If the cannon had a height of 0, how long would it have taken for that cannonball to come out of the cannon and get to the ground? It would have been on the ground already if the barrel of the cannon was on the ground. So the time would have been 0. So 0, 0 should be a data point, or the graph should go towards 0, 0. Is this going towards 0, 0? It's not. Try the power option, power series option. Does that look like it's heading to 0? That's what the right one. That's how we know. Okay, plus it's fitting all those data points perfectly. For the label, say use equation. And again, we should see time in seconds for the blue dot, and then we get this equation 0.452x to the 0.499 power. That's like to the half power, which is a square root. Okay, click this graph and bring it down into the space for step 2. Go, and I think I have to make it just a tad bit smaller again so it fits. And that covers up step 3. We good? Can we go on to step 3 of this? Making another graph. This one wants the range versus the height. Look at where the range is and where the height are. They're as far apart as we can get them. Unfortunately, you got to select the whole thing. Start with height, shift key down, arrow over to range, arrow down to 14 meters for the height. You get the whole table selected. Insert your chart. Change the chart type to scatter. Okay, data range is B2 to E9. X-axis is height in meters. Which of these 3 things for series do we want? This is the range. Get rid of the initial speed, remove it. Also get rid of time. You just want the range. Say use row 2 as headers. Go to customize. Do your chart and axis title. Start with your chart title. This is the range versus the height. Go to your horizontal axis title. This is the height in meters. Go to your vertical axis title. This is the range in meters. Collapse that menu. Go to the horizontal axis. Set the minimum to 0 so we can see the y-axis. Now we're going to add our trend line, which is under series. Linear is not a good fit. Again, let's think about this. The barrel of the cannon was on the ground. It wouldn't have taken any time to go out. So what would have been the range? How far out would it have gone? 0. It should be going towards the origin. So figure out which of the 2 curves are the correct ones. Is it polynomial or is power series the better option? Which one? Power series. Then for your label, say use equation. And it should say range in meters, and then you have an equation to the half power. Click and drag your graph down into step 3. Into that shaded section. And once you have it, we can now go on to the analysis. Can we all do that together now? All right, let's go to the analysis. So these are going to be based upon the results we saw in the lab. Answer these in complete sentences with me. So let's start with our first question. I'm going to make mine a little bigger. What effect, if any, does the initial speed have on the time of flight? Well, we tested initial speed in part 1. Let's take a look. Initial speed and time of flight. I increased the initial speed. What happened to the time? Stayed the same. So is there any effect? None. So changing the initial speed has no effect on the time of flight. No effect. We saw that in the lab. Number 2, what effect, if any, does the height have on the time? So that's part 2, right? Part 2 tested the height. Let's look at the data. I increase the height here in the left column. What happens to the time as I increase the height? It increases. So that's what we want to say. Go to the analysis. Increasing the height causes the time of flight to increase. All right, now I want to know about relationships between the initial speed and the range. Initial speed is in part 1. Let's look at the graph of the initial speed versus the range. or range versus initial speed, sorry. What is that graph's relationship? You should be able to name it. What is the name of that relationship, Takari? That is a direct relationship. That's right. So there is a direct relationship between initial speed and range, period. Number 4 wants to know the relationship between the height and the range. Height is part 2. So go to part 2 and let's look at the graph of the height versus the range. What shape is that? It's a parabola. Now you gotta remember what the relationship is if the graph is a parabola. Starts with a Q. Nick? Very good. There is a quadratic relationship between height and range. There's a quadratic relationship between the height and the range. Okay, number 5 has 2 parts. This is seeing if you can understand what we just tested in the lab. We have 2 toy trucks that are going to roll off the same table, like this one here. We got 2 toy trucks that are going to roll off the edge. One truck is going at 2 meters per second. The other is at 6 meters per second. Which of those 2 trucks is going to be in the air the longest? So what we're changing is the initial speed. Did the speed have any effect on the time down to the ground? Look at question 1. Okay, so which is going to be in the air the longest? Okay, both trucks will be in the air for the same amount of time. But which one lands further from the table? That means which one has the bigger range. So if you look at question number, where's the range? Question 3. This is where we looked at speed and range. Notice we said there was a direct relationship. So if I want the bigger range, what type of speed do I need? A bigger speed. So which one's going to land further away? Okay. The truck moving at 6 meters per second will land further away. See, you're explaining that you understand what we just learned and applying it to a specific situation. We're going to do the same thing again here in number 6. We're going to launch a projectile horizontally, and we want to make it have the biggest range possible. But we can only throw at a max speed of 25 meters per second. So what should we do to maximize our range? There's 2 things we want to make sure we have to give us the biggest range possible. Let's take a look back at the questions where we talked about range. That was question 3 and 4. I want to have the biggest range. So according to question 3, what do I need to have the biggest range? According to question 3. Janelle? I need the maximum speed possible. Look at question 4. What else am I going to need to give me the biggest range? What does question 4 tell you? I want the biggest range. What do I have to do to my height? Or look back at the graph of heights and ranges in part 2. What do I have to do? Increase the height. So what should I do in number 6? Increase the height as much as possible and launch it at 25 meters per second. So to maximize the range, we should launch the projectile at 25 meters per second from the highest height possible. Make sure you hit enter after that so the end is selected. The lab is done. You can now turn it in if you've checked it all over. If you haven't checked it, check it tonight and submit it. It's got to be turned in before tomorrow's class.
Will you show the data table for part 2?
You can check it on the video. It's on the video from tonight's class. So later on, you can check it and turn it in before tomorrow. Okay. But we got to stop class now because we have another